So you're using the mobile phone. Can you see something like raise your hand or something? Like a
Yes,
hand.
please.
Press it, let me see. Yes. So whenever you want to pause me or ask any question, you press it, okay?
Okay.
Yeah.
Thank you.
Yeah. So today we are going to start with motion, as we said. Um so what we'll do is that we'll get first, let's define what motion is basically. So let's assume that we have a ball over here or a body over here or a body over here, and then let me draw a ball rather. So let me say we have a ground. This is the ground, and then we have a body on the ground. So then they ask us, how do we know that a motion has occurred? A body is said to be in motion if, as time is passing, always time is always moving. Time is always moving. Whenever, as time is moving or time is changing, when the body's position changes with time, then we say that motion has occurred. If the position of the body changes with time, let's say 1 second, the body is here. 2 seconds, the body is still here. 3 seconds, the body is still here. Then motion has not occurred. But if 1 second the body is here and the second position after the seconds 2 second, the body is here, and then the third time the body is located over here. So you can see the body that was here first is finally moved to this place. The position of the body has changed over time. That's when we said motion has occurred. But if the body stays at one place without changing any position as time is passing by, then we say motion has not occurred. So what is motion? Motion is said to occur when a body changes its position with time. As time passes, when the body changes position from one position to another, that's why we say motion has occurred. Okay, then when it comes to motion physically, we need to do the mathematical aspect of things. It's going to be mathematical aspect of things. There are two kinds of motion that we'll be looking at. So the two types of motion that we'll be generally looking at kinet, kinetics and kinematics. Kinematics. So we need to be looking at these two. So how what's the difference between what are these two things? If you look at the only difference between these two words is the introduction of the word ma. So it's kinetics, right? This is kinetics, and the other one is kinematics. Yet there is only difference that there is a ma between the e and the t. So kinetics, we just put ma inside, it become kinematics. So the difference is that first we are going to focus on the body. Let's say let me have the ball over here, and we have someone here, and the person has pushed the ball with a force, let's say a force F, and the ball is moving, and the ball is finally at this position. This one is position 2, let's say this one is position 1. So what we are looking at over here, we are considering the force. There's a force that has pushed the ball to move from position 1 to position 2. If you want to study motion, of an object like the ball here, you want to study the motion of this object from one point, position 1 to position 2, and you are considering the force that caused the motion. If you are considering the force that caused that motion to make the body to move from position 1 to position 2, if you are focusing on the force inside, then you are basically doing kinetics. If you are considering the force that is causing the motion or the body to change or to move, then you are doing kinetics. But if you are not looking at the force, you are just focusing on the body alone, then we are focused that study is going to just kinematics. If you are studying the motion and you are considering the force that caused the motion from one position to another, that is called just kinetics. But if you are not considering the force, it becomes kinematics. So the study of the motion of a body without considering all external forces acting on it, that study is called kinematics. But study of the force putting into consideration all the forces that are acting on it. That is basically kinetics. Um, are we okay so far?
Yes, please.
Sure. Thank you. So we know what kinetics and kinematics is. Can anyone just help me with what they got so far from between the two, difference between the two? Is there anyone available to help us with that? So I'll confirm that we.
Okay, so what I got so far is
Millicent, are you
that
still raising your hand? You can stop this thing if you are not raising your hand, right? You can click
yeah.
on it again to put it down. Thank you. Yeah.
So what I got is that for the kinematics, it is the kind of motion that considers all external forces that act on the body. But for the kinematics, don't consider the external force that act on the body.
Which one don't we consider? We don't consider the forces. Which one?
Kinematics.
Yeah, okay, yeah. So kinetics, we just consider the forces, right? Good,
Yes.
good, good. Okay, thank you, Kennedy. So that's what we got so far. So how do we get the difference? So if we ask what is kinetics and kinematics, so the difference that this one is longer, right? This one is longer, but and then this one is shorter. There's the only difference is like there's a mark between the two. So the only difference between forces and no forces, forces and no forces. So you have to know that when there is ma inside, then there is no force. But when there is no ma inside, meaning there is a force. The way I used to remember it is that this ma, I consider it as um, usually most people call their parents or their mothers ma, right? So when your mother is present, right, you feel like, oh, you are more secure. There won't be much external forces acting on you or anyone bullying you around. So when there is man inside, meaning that there's no external force together, it's as if you are protected. That's how I used to remember it. So man for like mom, something like that. So my mind is like, okay, when they say kinematics, then I know that okay, there is a mom inside. It means that there's no external force that's going to act on the motion of the body. But when they say kinetics, the mind is not there. So it means that all external forces into the body is going to be considered. That's an analogy that I use. Um, does it confuse you or does it help?
It helps.
Sure. Millicent, what about your end?
Okay, please it helps.
Okay, thank you. Now we know what kinetics and kinematics is. So what do you think we are going to start with? We need to first start with, we are going to focus on the motion. We are going to do the study of motion where we are not considering the force inside. The force that is packed, we are not going to consider that. So we are going to focus, take up between this and this, between this and this, we are going to take only one. And we are going to take the one that does not consider the force that's inside. So Millicent, which of them are we taking? The one that doesn't consider the external forces.
Kinematics.
Please, I can hear you.
Kinematics.
Yeah, good. Thank you. Kennedy, does that help? Is that correct?
Yes, please.
Okay, yeah. So there's we are going to first start with kinematics. So what is kinematics? Kinematics is the study of motion of bodies without putting into consideration all the external forces that on the body, all the external body, all the external forces causing the motion, basically. Now, how do we now when it comes to kinematics alone, what are the parameters or the terms that we need to use? So we need to focus on some terms. There are some terms that you need to be used to when you are doing kinematics alone. And these major terms are just going to be something simple like SUVAT. SUVAT. This is the SUVAT. These are individual terms S, U, V, A, and T. So the S is for some kind of confusing, but then it's for distance. The S is for distance. So let me put it here like S is going to be distance, the distance traveled by the body during the motion. The U It's also going to be confusing, but it's like initial velocity. Initial velocity. This is the velocity of the body at the beginning of before the motion starts. What was the velocity of the body? And then v is the final velocity. Final velocity. And the last thing, oh no, the last two, the next one, a will be referring to acceleration. Acceleration. And then t will definitely be for time. T will definitely be for time. So SUVAT, these are the terms that we need to use, we need to understand when it comes to kinematics. That's study of the motion. We are not considering the force, so you cannot see anything force inside the SUVAT. S for distance, U for initial velocity, V for final velocity, A for acceleration, and T for time. Good. Now, these are the terms that we'll be working on. But before that, now that we know the terms, we'll define them properly. But then first, let's understand the kinds of motion that these ones can be involved, that the kind of motion that these terms are used in. So let's go and focus on what are the types of motion. Types of motion itself. So what we did first, the kinematics and kinetics are basically the two kind of study of motion. This one, they are like studies of motion. So the kinematics is a study of motion that deals with motion of a body with external forces taken into consideration. Kinematics is the opposite. But right now we are going to look at the types of motion themselves. So that doesn't confuse you guys. What we look, kinematics and kinetics are the studies of motion, the types of studies of motion. But types of motion are going to be the different variety of motion that we can see out there. One of them, there are many of them. So we can have motion occurring on a straight line. That's a linear motion. We have a motion that is linear. Then we can have one that is acting on a circular path. So that will be circular motion. Circular motion. Yes. So we have linear motion, circular motion. Those ones, they act. Circular motion definitely acts on a circular path. Linear motion acts on a straight path. Then we will also look at projectile motion. Projectile motion. There will be something like rotational motion, another type of it, and then linear, circular, projectile, rotational, and there are other kinds like simple harmonic motion that we'll be looking at. But let's start from the basic one. Let's not go too much into all the types of motion. Let's take it one after the other. The very basic one is the linear motion. So linear motion, that motion that occurs on a linear path, like a line, the word line, so straight line. So it's like on a straight path. Circular motion occurs on a circular path. Projectile motion, I'll probably define that, but then if you throw something in the body, you throw something into the air like this, the thing will go and fall down. It's like you throw a stone. When you throw a stone, the stone goes up like this and then falls down like this. This is a projectile motion where you project the body at an angle and it moves under the influence of the gravity and falls down. Don't worry about those terms. We'll actually take time to understand them. But right now, we are just looking at generally the types of motion. So linear motion on a linear path, circular motion on the circular path. Right? Those are the very basic one that you need to know, this and that. So let's be clear on those ones and then try to make the actual differences. Now, before we move on into details to take them one after the other, before we take them one after the other, I want us to actually appreciate something unique. That's the difference between these two: circular motion and rotational motion. Circular motion and rotational motion. So what happens is that in both of them, there is some turning. In circular motion and rotational motion, there is some turning. Now, the concern is what you are turning about. We usually turn about something. You turn around something. What you are turning about, or the center around which you are turning, because a circle definitely is a circle, and the circle has a center. The circle has a center. So if you are doing a circular motion, definitely there will be a center around which the body is creating the circular path kind of thing. So if the focus should be where that center is, if that center is inside the body itself or outside the body itself. If that center is inside the body or outside the body, that's what makes the difference. For circular motion, the center around which we are doing the circular part, or we are moving, we are turning, is outside the body. Let me make a I'm coming. Let me give an illustration. Let's say your car gets to a roundabout. Let's say you are in a car and a car gets to a roundabout. You see, usually roundabout there is something in the middle and then cars are moving around it. Right? Maybe you are moving from here and then there is a roundabout. So cars are moving. You can pass here. So there is always something circular here. So to the other side, there is one that you can move to this side. Roundabouts are usually like this. It's so don't mind my drawing. So yeah, so when you are moving from here, let's say you are the body here, you are moving from here, you can decide to move here and here, or you can decide to move here and come and pass here, something like that. So around this, you are the body. When you get to this junction, you take this part and you begin to make a circular. See, from here to here, you are doing a linear motion because you are moving on a straight line. But when you get to this roundabout, you are moving outside around a particular turning point. You are turning. Now, when you are describing this turning, when you are moving around this turning, right, you realize that what you are turning about is outside. You are turning about this, and that thing is outside the body. This is the car, and then you are moving around. Let's say you reach here, so you'll be describing this circular part around this roundabout monument, right? So what you are turning about is outside your body. If the what you are turning about is outside the body, that's when we have a circular motion. That's when you are doing circular motion. But if what you are turning is inside the body, if it is inside the body itself, then it becomes a rotational motion. So let's say like you are spinning something. You can have something like let's say you have the fan, the ceiling fan. The ceiling fan has the center here and the blades are here. The blades are here. So the ceiling fan usually turns and it's turning around itself. It's turning around itself. So the thing is turning around itself, right? So this center, this body, this fan head, this fan head is exhibiting actually a rotating. It is rotating. So it's actually doing a rotational motion. So in rotational motion, what you are turning around is inside the part itself or the fan itself. So that becomes a rotational motion. But if the turning is around something that is outside, we call it a circular motion. Any question, any confusion? Is it clear so far?
Yes, please.
Yes.
Okay, good. So we know what the two types of motions are. Okay, so circular motion and rotational motion are well taken care of. And then projectile motion, yeah, so now we come back to that. Now we know what circular motion is and rotational motion is. So I'm going to give some examples, right, to see if you tell me which ones are, if it is that motion is circular or rotational. It is going to be circular or rotational. Millicent, this question is for you, right? So we have a car, right, and the tire. Let's say we have a. I'm just doing one tire of the. Don't mind my drawing. So let's say I have a vehicle. And then we are focusing on this tire, right? When this tire is moving, what kind of motion is it doing? The tire alone is turning, right? It's turning. But which of them? These two, this and this are doing turning. But which of them do you think the tire is doing? Millicent,
Rotational motion.
why do you think so?
Because The car is not moving around anything. It's moving on its own axis.
Yes. So it's turning on its own axis. So that becomes basically a rotational motion. Kennedy, are we okay with that too?
Yes, please.
Okay. So those are the basic types of motion that we have. So we are going to focus on the linear motion, and the linear motion will be using, yeah. So in all this type of motion, we always have to use these terms. Suvat will also always come in. So yeah, so yeah, let's start with linear motion. When it comes to linear motion, a lot of people get the very basic one. Let me clear this. When it comes to linear motion, yes, so this is linear motion. We are now focusing on only linear motion from everything that we've learned. In linear motion, there are, I want you to see, like, there is going to be linear motion on the ground from one point to another, straight line. A straight line from here to here. This is one linear motion. So let's like how a car is moving from point A, point one to point two. This is a linear motion before it's moving on straight line. There are other kinds of motion that we actually see when you are on the ground. Let me do this one as the ground. So the body is moving from here to here on a straight path. That becomes a linear motion. That's one kind of linear motion. Another kind of motion, let's say the ground is here, then we throw the body up here. This one is also a linear motion. You have something, then you throw it upward, upward motion. So you are moving a straight. The thing is, at the end of the day, you are moving in a straight line. That's what we look at linear motion as. Even if the body is moving at an angle like this, right? As long as it is a straight line, that's a linear motion. Another thing is that something is at the top, the ground is here, and it falls, right? And it falls down. So that's free fall. So this one too is also another linear motion. So under linear motion, we are going to look at it as, we are going to solve questions, or yes, analyze them on the ground level, on the, to the ground level first, on the going up, on the going down, and then we are going to combine these two such that if we throw a body up, the body will go up and then will also come down. So it's going to be the combination of this, this, and this. So, but before you can master this, from there, before you can master this, you need to know the very basic one. We need to make sure that we understand the very basic one on the ground, top, down, before we come to the one that combines both. Then from there, if you're able to master this one, if you're able to master this going up and down, then we can quickly translate these two into the next type of motion, which is projectile motion, throwing a body at an angle to go up and fall down. So yes, that's one. Then when you're able to do projectile, then we finally go to circular motion, which is going to put everything in a circular and then move to rotational motion. So that's how the things are connected. I like putting the things in map so that when we are learning, you know where we will get to next, or you look at the vision where we are getting to, and why it's important to spend time on this one before we move on. So we are going to start with the linear motion, raw ground, then go up and go down and go up down. Then after that, we'll move to the one that you project at an angle from here. Then then we'll finally navigate to circular motion and rotational motion. Then we know that we are done with a major part of motion thing. Then after that, after we know all these basic motion, now we now go and focus on now the force we are going to put on the external forces now, including now, because we have taken time to understand the motions themselves without the force. After we know them, then we go back and then we say that okay, now let's include the force. If we include the force, what is going to change? What is not going to change? All these things are going to come into play. So I just gave you the map of what will be going under motion. So yeah, so when we are at every stage, we need to make sure that we take time to understand those stages, clear every doubt. Yes, some people may have covered it already, but may have not understood it the right way. So let's take time to clarify them, starting from this basic one. But right now, do you have any questions so far?
No.
Great. Millicent, you have any question on your end?
No, please, no question.
Sure, sure. That's good. So let's, now that we know where we are getting to, everybody has seen the map and the vision. Let's start with the very basic one, which is the linear motion. So we are, let me call it linear motion on the ground, right? It's not written in a book like that, but because of the map we are doing, what I want to, how I want you to understand it, we are going to linear motion on the ground. So we are going to basically focus on the ground motion. Ground motion. So it's like ground to ground. We are moving from ground to ground, but on a straight path. So let me call it linear ground. These are my own terms so that you guys will know. So linear ground. So that means that we are doing a linear motion, but on the ground to ground. No throwing, nothing, everything from moving from one ground to another ground. Okay. So how do we use the SUVAT? There is going to be some equations using the SUVAT that's going to happen. This SUVAT are basically, we are going to use small s, we are going to use small u, we are going to use v, small a, and t. That's what counts in the SUVAT. S for distance, u for initial velocity, v for final velocity, a for acceleration, and t for time. So these ones have come with equations of motions. So yeah, so these are going to be the equations of motion for kinetics, equations of motions under kinetics. So the very first one, the final velocity is equal to initial velocity plus at, acceleration times time. This is equation one. This is equation one. Then there's s is equal to ut plus half at squared. This is equation two. And then the third one is v squared equals to u squared plus 2as. So this is also equation 3. These are the three equations of motion that we'll be using. We'll just be modifying this equation throughout for all the types of motion that we'll meet ahead. All the types of motion. We'll be modifying these equations throughout. So we need to take time to know how to use these equations very, very well. So you see, in each of them, there is something missing all the time. In the SUVAT, among the SUVAT, in each of them, there is something missing. In the first equation, the missing one, so the term that is missing over here is, let me put it generally at the top here. So let me do missing. So the missing term. So that when we are choosing your equation based on the parameter they give you in a question, you know what equation to use. The missing term here is, what do you think is the missing term? What do you think is the missing term in that among the SUVAT? We have the SUVAT, right? But then in the first equation, which of the term is missing?
The distance,
Yeah, the S is missing. So yeah, the S is missing. It's going to apply to this one. What about the second one? If you can quickly, let's go. What do you think is missing in the second one?
Final velocity.
Yeah, so V is missing. And then the third one,
time,
yeah, time is missing. But there is one guy that is never missing.
acceleration,
Acceleration and
Initial velocity.
yes. So those two are missing. So but most questions are given around these guys. So when they give you a question where you need to look at the missing terms, what they are looking for. You need to look at what they are looking for. So let's say a question where they are looking for acceleration, but they have given you They are giving you velocity. They've given you velocity and let me clear stuff. Yeah. So let me say that we have a question where they are looking for A. So let me put question mark here. But they have given you V. They've given you V. They've given you U, right? And they've given you T, right? So which of the equation do you think will be using? So let's say, yeah, they gave you V, U, T. Let me do it like this. They give us V, comma U, comma T, but they are looking for A. It's A that they are looking for. So how do you choose which equation to use? The way you do it is that you look at what they give you. You look at all these equations. You look at what they give you. You include them, the one that are giving you, you put them in all the equations, and then the equation that give you only one missing term, the equation that give you only one missing term, then you can use that equation. Coming in, I'm coming again. When they give you a question, and the question has provided you velocity, initial velocity and time, and they are looking for acceleration. Look, put them, the one that they have given you, the one that they have their value in the question, put them in the equations, and then look for the one. Make sure that you choose the equation that only one term is missing. For example, if they give us V, U, and T, for this particular first equation, V is given, U is given, A is not given, but T is given. So it means that this question, we can easily use the equation one. So that's a technique of finding which of the equations to use. Sometimes, let's say they give us V, U, and they give us S. They give us V, U, and S, right? So they give us V, U, and S basically. So what I want to do is that based on what they ask you, but then first we need to choose which equation to use. So let's say they give us V, so I'll choose this one. So V is given, U is given, and S is not given, right? So meaning this one is not given, this one is not given. So two things are missing in this equation. Two things are missing, so we cannot choose the first equation. Now we come to the second equation. S is given. The thing they are giving us is VUS. So S is given, U is given, T is not given, A is not given, T is not given. So like three things are missing. So we cannot use it. The thing is that only one thing should be missing. So if what they have given us, we cannot use this equation and this equation. Go to the last one. V is given, U is given, S is given. So and only this guy is not given. This one is two is a number, so we know two already. A is not a number. So it means that based on the question, I have to use this equation. Those are the techniques to actually help you choose the equation without wasting much time, right? I don't know whether you guys get it.
Yes, please.
Okay. Then what if we give us an equation where um let me give one to each of you, right? So the inside the equation they have given us um let me clean this one. They've given us S, they've given us U, and they've given us T. They've given us these three things. This one is for Kennedy, right? Kennedy, which of you look at this one, you tell me which equation that is appropriate for us to use. And then Millicent, yours, they give us A, they give us U, and they give us T. No, give us S. Yeah. So this is for Kennedy. Kennedy, I'm listening. And you take me through how you're able to get which of the equations to use.
Okay, so I'll pick the second equation because for the second equation, only A that is missing. We are given S, we are given U, and we are given T.
Okay, yeah, so why are you not using the second one, the first one?
Because for the first one, there's no S in it, and only two variables that are missing, which is V and E.
Yes, two variables are missing. So the focus should be two things should not be missing. It should be only one thing should be missing in that equation. Thank you. Well done. Let's get to Millicent.
Please, I'll choose the third equation.
The third equation. Oh wow.
Yes,
Why?
because AU and S is given in the third equation.
Okay.
Yeah, it's only one variable
That's missing.
missing in the
Okay.
third equation.
So tomorrow when we bring the questions, variety of them, and you can even bring some of the questions that you are having difficulties from whatever you are learning, whatever you have. You can bring those your questions so that you can also test them using the concept of just around linear motion. Right. So in tomorrow's session, let's try to come early so that we can save more time. It's almost it's 6 minutes to time. So I don't want to take much time. It's 8 to 9 class. So let's try to make sure we build a concept, building the concept tomorrow as well. So tomorrow is going to be solving questions mostly. So let's come and then what we've learned, we apply them to solving multiple questions. When we're able to do it on linear motion, then we can move to the other types of motion and see how to go about them. Are we fine?
Yes, please.
Yeah, so by
Yes.
yeah, so I'm closing at this 6 minutes to time. So um basically something new that you have learned, maybe you some of you have seen it before, but then there's a unique way that you have actually found that, oh okay, this is the right way I should have understood. Or if it's a first time something, you can also clarify. So I want you guys to say something around yeah what we've learned, something that's new. Don't tell me things that you know already. Yeah, anyone can go.
So for today's session, I have learned the difference between kinetics and kinematics, and I've also learned some of the major terms in the topic motion.
Okay. Millicent.
Okay, so I learned about the Stewart, the short form of the distance, initial velocity, and final. I didn't know there was I could use the Stewart for that. So
Okay, sure. Now go and sharpen your strengthen your understanding. What we'll do is that we are recording it, we'll save it on YouTube. If you forget, you can still go and then refer to them. But tomorrow we are all solving questions together. We'll all explore the answers together. So tomorrow bring your calculators along. We are going to mostly be solving questions. When we confirm it, then we go to the other types of motion. I hope by the end of this week we'll be able to cover all the types of motion if we move at this pace. Yeah. Thank you very much for coming. Let's see you tomorrow.